All right, thank you so much for joining me today. We're going to be learning about shapes today. Okay. We're going to be looking at two-dimensional shapes or 2D shapes. We're going to specifically be looking at polygons. All right, so let's go ahead and take a look first at what is a two-dimensional shape. Okay, so a two-dimensional shape has height and length. So if I take my ruler here and I say make about 5 centimeters down, I can consider that my height. If I go another 5 centimeters across, I can consider that my length. All right. So I'm going to go ahead and continue this and make a square. So I've just defined what a 2D shape is. It has height and it has length. Some people consider it height and width, okay, or length and width. But regardless of what you consider it, all right, the fact remains that it only has 2 dimensions. It's missing a 3rd dimension. Okay, so what do I mean by that? Let's take a look. Let's help define it. So let's take a look at what is a 3D shape or a 3-dimensional shape. Okay, so I'm going to do the same thing. Excuse me. Do the same thing. We're going to go 5 centimeters down. Okay, so I got my height. I have my length. And I'm going to continue with this all the way around to make my first 2D shape, and then I'll show you what a 3-dimensional shape looks like. Okay. Two dimensions, height and length. Okay. Now what I like to do, in order to kind of make this a box, okay, is I try to find where the center of this square is, this 2-dimensional object, okay? I could be real precise by measuring, but I don't want to. I'm just demonstrating. So I'm going to say there. I'm going to try to find the center of it, okay? And then what I'm going to do is make another 2-dimensional box, or rather not box, but a square, starting from the middle. Okay, so what I want to do is I want to have 2 squares that look exactly the same next to each other. Kids love to do this when they learn how to make 3-dimensional objects. Okay. This is a solid line because I can actually see it. If, say, I was viewing this shape looking this way, I would be able to see that corner. Okay? Suppose I would be able to see this one too, but it's usually like broken like that. Be solid. Not the best, but that's all right. Okay. Okay, now we have a cube instead of just a square. Okay, now I'm going to add the third dimension, which is width. So I have my height. Here. I have my length. And now I have the third dimension, which is width. Okay, you can solve for the area of the cube by multiplying those three dimensions, but we're not going to look at that right now. This is basic so far. Okay? So that's why they call it three-dimensional or 3D, because now you have this other dimension that allows you to put stuff inside of it. Okay? So a 3D shape, one way to define it for children is you can put things in a 3D shape. Kids really grasp that idea. They understand what a three-dimensional object is when you tell them you can put stuff inside of it. Okay, so it is good to define the difference between a 2D shape and a 3D shape for children. So I'm going to take this off now. You can tell that this has been having some use in the classroom. All right, so we want to take a look now at two-dimensional shapes. Okay, and I was able to get this one offline for free. Okay, and I'm thrilled that I was able to do that, so thank you. Okay. Now, okay, remember, these shapes here have height and they have length, but they don't have width. You can't put things inside of these. Okay, not without adding that other dimension. All right, so let's just go ahead and take a look at these. Okay, and then I'll show you some different activities we can do because I've cut these out. All right. This is very good to be able to have and to have two sheets. Okay, so we have our square, obviously, a rectangle, a circle, an ellipse, an equilateral triangle, an isosceles triangle, a scalene triangle, a right triangle, a rhombus, a parallelogram, a trapezoid, a kite. We have a regular pentagon, regular hexagon, regular octagon, and a regular decagon on this 2D shape sheet. Okay, so I'm looking at this here, and the next thing I'm going to teach is the idea of what is a polygon. Okay, because all of these are polygons except two shapes. Two shapes are not polygons. Do you know which ones aren't polygons? Okay. So in order to understand what a polygon is, let's first define it, okay? So I'm gonna get my dry erase marker. Okay, the word polygon means many angles. Okay. Means many angles. Okay, so literally poly means many. Go like this instead. Okay, and gon means angles, or yeah, angle, whatever. Okay? Shapes that have many angles are called polygons. Okay, so the first thing I want to do in order to really understand what a polygon is to understand what it isn't first. What isn't a polygon? A polygon is a shape that doesn't have first thing is curves. Doesn't have curves. Okay. So I'll take my ruler, for example. Okay. Maybe I make a straight line like this. Maybe I take another straight line like this. Okay. And then I make something like this, right? Like a snow cone. That's not a polygon because it has a curve. Okay. The second thing is a polygon. A shape is not a polygon if it has a gap. Okay, so let me show you what that means. So a gap means that at least one of the side is not connected to the other side. Okay? A gap or gaps. So this is a gap here. It just means that it's not connected. That's all. Okay? Another thing that makes a shape not a polygon is what's called an overlap. Okay, and of course that means curve or curves, gap or gaps, overlap or overlaps. Okay, so let's take this idea here of this triangle that I was going to do. I'm going to create an overlap now, see? Okay, so an overlap means that one of the sides extends through another side rather than meeting it at a point. Okay. Okay, so let's review these ideas real quickly. Okay, what isn't a polygon? A polygon is a shape that doesn't have curves, curve or curves, a gap or gaps, an overlap or overlaps. Okay, so that's going to really help us to be able to define what a polygon actually is. Keep it this way. What is a polygon? A shape with many angles. Okay, so it's a shape. A polygon is a shape that has straight sides. Okay, first of all, straight sides, number one. No curves. Okay, secondly, a polygon is a shape that has I'm going to say this, I'm going to say meets at a point without an overlap. Okay. A polygon is a shape that has at least three sides, three vertices, and three angles. Okay, so what does Mr. M mean when he says this stuff here? At least three sides, three vertices, and three angles. Okay. Well, let's take a look. We'll come back to that in a second. The most basic polygon is a triangle. Okay, so I'm going to make a little triangle here. I'm going to try to do an equilateral triangle where all of the sides are equal to 2 inches. There's another name for that. It's called a regular triangle. And this isn't exact, but that's okay. You get the idea. It's not perfect. That's fine. Okay. So now, going back to this idea that it has to have at least 3 sides, 3 vertices, and 3 angles. Polygons can have way more than that. Okay, way more than that. But that's just the most basic one. Okay, so one of the things that we do in geometry is we like to code. All right, so it has 3 sides, like one side is here, side, side, and side. So there's 3 of them. So a triangle has three sides. Okay, now what does it mean to have a vertices, three vertices? Well, let's take a look. A vertex is one. It's where the two sides meet each other at the point. Okay? And I'm going to put these in red. So I'm going to put A. B is it has three vertices. Okay, I'm going to make a note over here. Vertex is singular. That means that there's one. Vertices is plural. That means more than one. Okay? So if I'm just looking at this one, that's a vertex. It's only one of them. If I'm looking at more vertexes, it's called vertices. Okay. And a vertice is where the points meet. Definition. Or actually where the sides meet into a point. You can also think of this as a corner if you want to. That's fine. Okay, remember what a polygon is. It means many angles. Okay, now these are the angles. They're actually inside. Okay, and I'm going to do this in red once again. I will show you how to measure angles. But for now, I think it's best if we just understand that there's three of them inside of the triangle. Okay, they're called interior angles, but for now we're just going to understand that there's three of them. Three angles. Okay, so I'm going to label it too so you can see it. Vertex here, here, and here. Okay, and of course we know that if it's more than one vertex, it's called a vertice. And then we have angles. We have three of them. We have an angle inside, here, another angle here, and yet another angle here. Okay, so why is a triangle the most basic polygon? It's a good question. And it's one that I always ask my students, and it's difficult for third graders to understand at first. The most basic polygon is a triangle. If you have straws at home and twisties, it's the best way to be able to demonstrate to children. I don't have those with me right now. Okay, so I'm just going to use I'm going to use pencils as an example. Okay, and we're going to imagine that these two, the vertex here is actually comes together and it's together. Okay. Notice this is not a polygon. It's only two sides. I would need a third side in order to make a shape that's a polygon. Okay, that's why a triangle is the most basic one, because you need, oops, and I put polygo. Okay, you're going to need a third pencil, aren't you, to make a triangle? Okay. And we can go into so much detail about the sides of the triangles and things like that, okay? And I'll do some instructing on that here in a second. All right, so we obviously, in order to make the most basic polygon, which is a triangle, you need at least 3 sides, at least. Other than that, you're not going to be able to make one. So that's just a quick little demonstration of that. Okay. All right, the next thing I want to take a look at is I want to go back to here. I want to go back to the 2D shapes. Okay. Now, remember I asked that question earlier. I asked that question, okay, which ones of these are not polygons? Okay, so hopefully you remember the definition of what is not a polygon. And you remember that a polygon does not have curved sides. So a circle, even though it is a two-dimensional object, okay, it's not a polygon. Technically, it does have height and length, okay, but that's something else determined by the diameter of the object, pretty much, to be able to measure it, and that's not something you need to know right now. Just remember this: it doesn't have a base. Okay, if I were to let's imagine that this is plastic or something like that, right? If I were to put it on a surface, it would roll. Okay, all of these other shapes would not roll because they have a base to it. They have these straight lines. So if you were to actually put this on a surface, it would be able to stand. These would not stand. Okay, this ellipse here would probably rock back and forth like that, and you've seen that before. So, once again, these are not polygons, even though they're 2D shapes. Okay, so let's try to remember that stuff. Okay, good. What else do I want to talk about? Okay, so what is a regular polygon? That's going to be the next thing. What is a regular polygon? Okay. A regular polygon is a polygon that has all equal sides. That has all equal sides. Okay. So what do I mean by that? So I should be more technical and say that has all equal sides in length. Okay. Okay. So going back to my 2D shape here, okay, I see that these polygons on the bottom say regular. That's because the sides of them are all of equal length. See? Okay, so this is 2 centimeters across this way, and I know because it says regular that all of the sides are going to be 2 centimeters. Okay. Okay, so you get the idea. Just a little over 2 centimeters, but you get the idea. I wonder if it's an inch in US customary. Those of you that aren't from the United States, this is what our rulers look like. We actually have the US customary in inches. So these are millimeters. Actually, I don't even think that's a millimeter. My bad, that's not a millimeter. Those are fractions of inches. Okay? If you're not from the United States and you're part of the rest of the world, then you use the metric system. So these are millimeters actually. It's about the size of the tip of a pencil. And a centimeter is about the tip of my fingernail. Okay. So just go back and forth. Here in the US, we have to be able to convert measurement. Okay. But you get the idea of what regular means, okay? That's almost about 3/4 of an inch. And if you're at home and you have a ruler, prove it to yourself, okay? Measure the sides. And then you're getting some really good practice in just measurement in itself. It's about 2 centimeters in the metric system. And also, kids, remember, don't start here and measure. Okay, some rulers begin their measurement here off to the side. Okay, if your ruler's like mine, start here at this line. Okay. So anyhow, all of these sides are of equal length. Okay, that's why it's called regular. So the equilateral triangle, it says equal because all of these sides are triangles. You could also call it a regular triangle if you wanted to. That's fine. Okay. Now the square is a regular polygon as well because it has all equal sides. Okay, in geometry, one thing that we like to do is code the sides with what are called hash marks. Okay, so for example, this length here is equal to this length, which is equal to this length, which is equal to that length. Okay. What this indicates and shows, this little hash mark here, is that this length is equal to this length here with the sides. Okay. So watch what happens to the rectangle. Not all of the sides are equal. So I'm going to say this side is equal to this side. And now I'm going to do 2 hash marks, see? Oops, I just broke the lead to my pencil, see? So what this shows is that this length is equal to that length because they both have 1 hash mark. And this length here is equal to this length because it has 2 hash marks. Do you see? Okay, now we're going to look at the equilateral triangle. And I know that this side is equal to this side, which is equal to this side, see? That's why I have 1 hash mark for each. What makes these different triangles? I'm going to show you exactly what makes these different triangles right now. Okay? Is that the isosceles triangle has 2 sides of equal length, but it has 1 side that is not of equal length. That's what isosceles means. Okay, is that it has two sides of the same length, but one side is not the same length. And it always makes, isosceles triangles always make kind of like a point. Okay. Scalene triangle, on the other hand, all three of these sides are not equal to each other. None of the sides equal each other in length. Okay. So this side does not equal this side, does not equal this side, you see? So when the sides are of the same length, you use the same code or you use the same hash mark. When you add another side here that is not of equal length, you put another hash mark. This one has three different sides altogether, so we can't use the same hash marks. We must use different ones to show or indicate that they're different. Okay, so a right triangle here means that it has a corner that measures 90-degree angle. Okay, and the next video I do, okay, I'll show about measuring angles and stuff. But this symbol here means that it's a right angle. That's why it's called a right triangle. Doesn't mean correct or anything like this. Technically, this is a right triangle because it has that corner. And it's also a scalene triangle because it does not have equal sides. The three sides are of unequal length. Okay? So that's important too. So this is a scalene as well. Okay. Now if you take a look at this corner, you notice that none of these other angles actually have that corner at all. See? These do. In fact, a rectangle has 4 right angles, and so does a square. Okay, and we'll get into that more. I'm kind of jumping the gun here, but I'm just showing you. Okay, for an example. Great. Okay, now let's talk about these other type of triangles here, like a rhombus. Okay, a rhombus has all equal sides. Okay, it's also called a diamond. People like to call a rhombus a diamond sometimes, and it is a diamond shape if you kind of move it. Okay, now a rhombus is also a quadrilateral, meaning that it has 4 sides, okay? So we're good there. Okay, I'll get back to the idea of a quadrilateral here with 4 sides. When I'm working with shapes, I love to code the sides like this so I could tell myself that they are equal length. So rhombus, but a rhombus is obviously not a rhombus and a square are both quadrilaterals, okay? The rhombus doesn't have the 4 right angles though. And it's tilted, obviously. You see it kind of tilt there. A parallelogram has 2 sides that are equal length here, 2 sides across with equal length. Okay, now why is it called a parallelogram? And I know people love to ask that question, kids do. Okay, it's because these opposite sides, if I compare this side with the 1 hash mark compared to this side with the 1 hash mark here, and I just imagine these 2 lines going on forever, they'll never ever touch each other, ever. So the opposite sides will never intersect or cross. Okay, this is why it's called a parallelogram. Because the opposite sides are parallel and they'll never cross. Look at the trapezoid. Okay, if I were to look at this trapezoid here, okay, it has what's called one pair of parallel sides. Okay, this is one pair of parallel sides. But these sides here, if the line continued to go, they would actually cross. So that's called intersecting. That's why a trapezoid is not a parallelogram. Okay, we can get into some real technical stuff here, that a rhombus is a parallelogram, a square is a parallelogram, a rectangle is a parallelogram, because the opposite sides are parallel to each other. All right, but that's very difficult for a third grade child to understand. By the time, kids get into 4th and 5th grade, they can understand that better. Okay, even then, it's difficult for them to understand at first. Okay, so now if I take a look here, I can see that this side is of equal length to this side. Now I have this side that's different. It is not equal to the other sides. Okay, so I want to see if this one on the bottom, it's about 3 centimeters. How about this one? Yeah. So I have two sides that are 3 centimeters and one side that's 2 centimeters. So practice this stuff, kids. This is great. Great for your mind too, to be able to, and now you're measuring stuff. You're not just using a ruler as a straight edge, which I think is very important. Okay? A kite is kind of a weird shape. All right? I can tell that these two sides are of equal length, and then this side and this side are of equal length. A kite does not have opposite parallel lines. Does not. Okay? You can kind of think of a kite as being something very different than a parallelogram, even though they're both quadrilaterals. All right, and we'll do some activities here in a moment. Regular pentagons. Okay, all of these sides are going to be of equal length. Now, penta means 5, so penti actually, but that's okay, pentagon. So 1, 2, 3, 4, 5 sides. Or 5 angles is what that really means. A shape with 5 angles. Remember that word gon again. Polygons. We know that gon means angle. Regular hexagon. Let's see how many. 1, 2, 3, 4, 5, 6. A regular hexagon. 6 angles. Okay. Octagon has 8 sides of equal length, and this is a regular octagon. Like an octopus has 8 tentacles. Okay, an octagon has 8 sides or 8 angles. A regular decagon, this has 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 angles. Okay. Let's go back to this idea here. Okay, let's go back to this idea that okay, if you notice here, you're going to get the same amount for each polygon when you add a side. Okay, so for example, when I look at the regular pentagon, it has 1, 2, 3, 4, 5 sides. It also has 1, 2, 3, 4, 5 vertices. And it also has 1, 2, 3, 4, 5 angles. So every time you add a side, you're adding an extra vertex. You're adding an extra angle. All right, so try to keep that stuff in mind too. That's important. And then use little tricks to try to remember this stuff, like octa, okay, like octagon, whatever. 8. Deci, like a decimeter or a decade means 10. 10 years, decagon. All right, so try to think of stuff like that. All right, now, so that's what a regular polygon looks like. A regular polygon is a polygon that has all sides, all equal sides in length. Okay, so anytime I look at these shapes that have the same hash marks all around the shape, then I know that's a regular polygon. Okay, so it's important to understand this. So this is a regular polygon. This is not a regular polygon. This is a regular polygon, and it has a special name called an equilateral triangle. The isosceles triangle is not a regular polygon. And remember why it's called isosceles is because it has 2 sides of equal length and 1 side that is not of equal length, and it always makes this type of shape that's real pointy. These are not regular polygons because the sides are not of equal length. Let me double check this right triangle. That's a little over 4 centimeters. That's not quite good. The rhombus is a regular polygon. This rhombus is. The parallelogram is not a regular polygon. Neither is the trapezoid. Neither is the kite. But all of these obviously are, because all of the sides are of equal length. Okay, so remember that. Once again, what is a regular polygon? A regular polygon is a polygon that has all equal sides in length. Okay, so try to remember that. Now, I want to break the mold here with polygons because some polygons look kind of weird. Okay. Now let me make another pentagon. Okay, remember a pentagon just has to have 5 sides, so we can make it really weird. Okay, and a polygon has to have straight sides, right? Okay, as long as it has 5 straight sides, 5 vertices, and 5 angles, it's still a pentagon. Okay, so this is technically, you just saw me kind of just making some stuff up there. All right, but what I did is I just made 5 sides there. Okay. This is still a pentagon. I want to get rid of that overlap. Don't like that. It's not a regular pentagon though. Because it has 5 angles, 5 sides, and 5 vertices, but is not a regular polygon. And why is it not at home? You know. Because all the sides are not what? Are not of equal lengths. Okay? So let's take a look here. How many sides does it have? Side 1, 2, 3, 4, and 5. Okay? But it looks different. Doesn't mean it's not a pentagon, it's still a pentagon. It just means that it's not a regular pentagon. Okay? And then we have 5 angles in here. And then 5 vertices. Okay? It almost kind of reminds me of like a base in baseball, like one of the bases. Cool. So that gives you an idea of how to kind of get away from only thinking about this type of shape as a pentagon. This just happens to be a regular pentagon. All right. Good. You kids get it. You're smart. Okay, the next thing that we're going to do is to organize shapes by attributes as an activity, okay? And I'm going to show you what that means. Organize shapes by, and they're called 2 things, by properties or attributes. Okay, these are synonyms, by the way. Properties and attributes. Okay, so what that means is what they look like. Synonyms, they mean the same thing. I can say that I'm going to organize the shapes by properties, or I can say I'm going to organize the shapes by their attributes. Either one is fine. So by what the shapes look like. There's other properties of polygons, but for now we're just going to organize the properties and the attributes by what the shapes look like. Okay, good. And this is great for learning, okay? This is perfect for learning. Is what you do is you take your 2D shape and you start organizing them according to properties. All right, so for example, and you just do this over and over and you make different styles, okay? So, okay, organize the shapes by quadrilaterals Okay, the word quad means 4. Okay. And there's different ways you can think of quad. So you can think of like a 4-wheeler as a quad. Okay, you can think of a quadricep, which is a muscle in the human body. Okay, that's the muscle in the upper part of your leg. Okay, you can think of maybe quadriplegic. Okay, means that someone doesn't have use of their 4 appendages. So what quad basically means is 4. So organize the shapes by quadrilaterals or versus, or just put versus non-quadrilaterals. Okay? So you make what's called a T-chart. You go like this. Quadrilaterals. Non-quadrilaterals. Okay, so we're going to start there. Some kids love to put all their shapes like in a little box, and that's cool. You know, kids are pretty cool like that. They can put like a little box right here. This is just one way that you can organize your 2D shapes. Okay, and I'll show you this idea, and then maybe another one or two, and then that'll be it for this video. Okay, and then I'll go into more complex things with measuring angles and looking at different attributes of polygons at a different video. Okay, but this is perfect for what we're doing. Okay, so now I see that here's a quadrilateral because it has 4 sides. What I suggest you do, kids and parents, okay, is if you have this, try to have them identify which 2D shape it is. It's the trapezoid. And then when they say it to themselves, they're getting reinforcement that this particular shape, the trapezoid, is a quadrilateral because it has 4 sides. All right, and that's really smart for learning. Okay, here is a square which is a quadrilateral and has 4 sides. Here's my equilateral triangle or my regular triangle, and it has 3 equal sides, but it's not a quadrilateral because it doesn't have 4 sides. This isn't even a polygon, so it's certainly not a quadrilateral. My ellipse. Okay. This looks like a kite. Okay, my kite is a non-quadrilateral. It only has, oh no, I'm wrong. See, that's why we do this. My kite is a quadrilateral because it has 4 sides. 1, 2, 3, 4. And parents at home, if you want to, okay, have them write the name of it inside if you want, if you like. You don't have to have it on a separate piece of paper. Get messy with the learning. It's just about learning. It's not about having, really like pretty cutouts. So whatever works for you. If you want them to label the shapes, the 2D shapes, you can do that. You can write what the name is inside until they've memorized it. Okay? Okay, so here it looks like I have a right triangle, which is a non-quadrilateral. I have my scalene triangle, which is a non-quadrilateral. I have my parallelogram, which is a quadrilateral because it has 4 sides. Notice how I'm repeating this over and over. Okay, when you understand this stuff, okay, it's a lot of repetition and it's a lot of repeating it to yourself, okay, as a way for you to drill it in your brain, basically. Here's a rhombus, which is a quadrilateral, has four sides. That's my scalene triangle. It has 3 sides that are not of equal length. Here's my rectangle. That's a quadrilateral. It has 4 sides. Circle. It's not even a polygon. Okay. Is this my decagon or my octagon? 1, 2, 3, 4, 5, 6, 7, 8. This is my decagon. Here's my hexagon. Pentagon. That's not my hexagon. This has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. Octagon. Okay. So if you make a mistake like that, label it if you need to. Okay. Hexagon has 6 sides. All right, so, and then what you do, okay, so what I just did is I organized these by their properties or their attributes. So, organized. Shapes by their properties or attributes, however you want to say it. Same thing. Okay, and for this strategy, okay, what I did is I organized them by the attributes, whether they had four sides or not, whether they were quadrilaterals or non-quadrilaterals. Okay, think of this as like a deck of cards. Okay, now what you want to do is you just want to reshuffle the deck, and this is wonderful for learning, and it's fun. Okay, so now I'm going to change it. You guys get the idea now. Okay, so this time I'm going to separate them into regular polygons where all of the sides have equal length. Or non-regular polygons. Okay. Do a T-chart once again. Kids love a little box here. Okay, especially little children, little kids, they love it. Everything's in the little box. Okay. Practice, parents and students. My octagon is a regular polygon because all the sides are of equal length. My hexagon is a regular polygon because they all sides have equal length. So is my rhombus. The right triangle is not. The rectangle is not. The equilateral triangle is. The square is. The parallelogram is not. The trapezoid is not. The isosceles triangle is not. The decagon is. This pentagon is. This isn't even a polygon. It has curved sides. The scalene triangle is a non-regular polygon. The ellipse isn't even a polygon. It has curved sides. The kite is a non-regular polygon. Okay. And you just want to double check. Okay, all of these polygons here, if I were to measure the sides, they would have equal length. The non-regular polygons would not. Okay? All right, so that's it for this video. That's a good introduction to shapes. Putting them into categories and checking them for their properties and their attributes is very, very important for geometry. Very important for geometry. And it builds a lot of skills that the kids are going to need to be able to be successful with measuring angles and understanding higher level math like trigonometry and things like that. Okay, good. All right, I do want to thank this. I don't do this in my videos, but I definitely want to thank Math Salamanders for being so kind as to allowing us to, be able to just print this off. Okay, free math sheets, math games, and math help. Thank you, Math Salamanders. Okay, and I highly encourage you at home. Okay, if you don't have a geometry template, to get one of these. Okay. Which reminds me, guess what I have? Ta-da, a geometry template. I bought this one off of from Amazon. It was about $8, and this is cool. Take a look. It has a ruler here, US customary on this side, the metric system on this side. It has a semi-protractor. It has different circles. It has an ellipse. It has all these different sort of, what is this one? A 1, 2, 3, 4, 5, 6. There's a hexagon. It might even have a specific name. Here's a right triangle. This might even be an isosceles triangle. And then here on the top, it has specific names for this stuff, right? Tells you that this is a rhombus. And do you see these little codes right here? Look, this is what I was showing you earlier. Okay, little hash marks, letting you know that all of these sides are of equal length. Okay, and the square as well. So these are kind of universal codes to be able to tell that all of those are of equal length. Take a look here at this one. This is interesting. This right triangle. So here it starts with 2 hash marks on this side, 3 hash marks on that one, and then 4 on this side. Okay. However you want to code it, but just know that it's different. I'm a little bit upset because when Amazon sent me this, they stuffed it in my mailbox. All right, so it looks kind of weird, but I'm not going to worry about that. Instead, I'm just going to get to work. Okay, so I might even, just go ahead and make shapes. Regular polygon. Non-regular polygon. Make my T-chart and have some fun. Put my geometry template down and just get to it. I do encourage you at home who are watching the video to buy a geometry template. And the kids love it. They'll start making all kinds of different shapes, and they're learning, which is so important, right? They start making silly characters and things like that. All right, you get the idea, folks. All right, so what I'm going to do later, okay, is I'm going to show different ways to measure angles and things like that in a different video on shapes. Okay, but remember what we did today. Okay, we looked at, just for a quick review, that's always important for learning. Okay. A 2D shape, or 2 dimensions, has height and length. Some formulas and equations will say like height and width, and that's fine, no problem. I don't get caught up in that stuff. Instead, what I get caught up on is understanding that a 3D shape must have height, length, and width. All 3 of these. Remember that with a 3D shape, okay, it makes a container. You can put stuff in it. When children hear this, especially those younger ones, it really makes sense to them. Okay? Remember that a polygon does not have 3 major things. It does not have curves, gaps, or overlaps. Okay? A polygon does straight sides, and at least 3 sides, 3 vertices, 3 angles. And you remember that the most basic polygon is a triangle. Okay? Remember that a regular polygon all sides are equal. Okay. And remember that An attribute or property, they're synonyms, of a polygon is how it looks. It gets much deeper than that, but for now, just remember that. Review. 2D shape has 2 dimensions, height and length. 3D shape has 3 dimensions, height, length, and width. And you can put stuff in it, like a container. Not on it, in it. That's why we review the review. A polygon does not have curves, gaps, or overlaps. A polygon does have straight sides and at least 3 sides, 3 vertices, 3 angles. A regular polygon, all sides are equal. An attribute or property of a polygon is how it looks. And like I said before, it gets a lot deeper than that. Okay? And for a game or a challenge, separate shapes. Is that an A? I hope so. Separer. I'm getting too technical now. It's getting late anyway. I'm going to stick with the E. Separate shapes by their properties. So important. Okay? Polygons versus non-polygons. Quadrilaterals versus non-quadrilaterals. Okay? Triangles versus non-triangles if you're basic. Okay? It was an A. Look at that. Try not to be too much a perfectionist, right, folks? But there we go. The little things get to me sometimes. All right, folks, have fun. Practice, practice, fun. Practice. Practice fun. And practice fun. All right, good night, everybody. Okay, next video I'll show a little bit of how to measure those angles off of shapes and discuss other type of attributes of polygons. Good night.